Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, we will see three approaches to solve the problem, starting from this recursion method to the memoization or catching, and we will also go to the tabulation. So this is a typical DP problem with binary search. So first of all, I would also like to tell you that keep following my DP playlist where I am teaching DP from very basic to advanced, and if you are already following my playlist, then give a try to this problem on your own. This is I now I will not say that whatever the concept you have learned so far, this problem is very easy, but it is very doable. I will say it is very doable. So if you know about DP, or if you are following my DP playlist so far, if you have already followed that, you can try this on your own first and then continue watching the solution. So what is the question is that what is the maximum number of events that can be attended? So you are given an array of events where events of I is nothing but start and end and has a value I. So it's like that there are various events starting from some start time, start and ending at some end time. And if you attend that event, you will be occupied from the start to the end, and you will gain a value of some value I. Okay. And if you want to attend this event, you will receive a value of I. You can only attend one event at a time, definitely. You choose to attend an event, you must attend the entire event. Note that the day is inclusive, that is, you cannot attend two events where one of them starts and the other. Then it's inclusive function. That's what it is told. Return the maximum sum of values you can receive by attending the events. Okay, return the maximum sum of values. Okay. So, first of all, this might look like a take not take DP. Okay, that well, if I'm in the current index, what should I do? Should I attend the current meeting? Okay, so first of all, let's say we have an event. Event is represented by three terms. Okay, start, end, and value. But I am telling that, let's say it's an event one, event zero, let's say event one, until we have some n events. Okay. Now you can go to you can first the first thing which should come to your mind is that you should see each and every event, and whether decide on two criteria, whether to attend the event or not attend. Okay, first of all you can think like this. Okay, but the thing which should come to your mind immediately is that in doing this, how are we exactly uh, how are we exactly understanding whether we are overlapping any case or not, whether we are overlapping any case or not. So this thing you should come you should try to think next. So the next thought process should be, first of all, this should be the first thought which should come to your mind. The second thought which should come to your mind is that how to remove this overlapping case. First, that thing you can ensure by, so first of all, sorting this. Okay, sort the ranges. Okay, so now let's say the initially the ranges were something like this, that let's say this is an event, let's say this is start time or end time, this is an event, this is another event, this might be another event, this might be another event. So now what will happen after sorting them, it will be something like this will be the event, this will be the next event. Okay, you see, after sort by the start time. Okay, sort by the start time, so that you ensure that after ending only you start something. So what to do if you have something like this, then this is another one, this is another one, and this is another one. Okay, so sort the indexes, sort by start time. But does this ensure complete overlap unoverlapped? Okay, no, no, right? So, what is the criteria of overlapping? What is the now the things which should come to your mind? What is the criteria of overlapping? So, the criteria is that if you are taking, let's say, this index, if you are, let's say, taking this index, this event, okay, let's say something like this, if you are taking this event, if you are attending this, you are occupied till this point, you are occupied till this point. It means that any event which starts before this point, let's say this, you cannot take. You cannot take this. You can only take those events which start after this. Okay, so this is the one which is starting just after this, and you can take it, and you can take it. So we will definitely do a take not take DP. Okay, we will definitely do a take not take DP. And the thing which should come to your mind here is that we can take only if my current starting index is greater than previous taken ending index. How do you understand by this? Among the indices which I have already, among the ranges which I have already taken, my current starting index should be greater than that. So my current starting index, let's say what was here, this is my ending index and this is my starting index. So this should be greater than my previous value. Okay, so if you try to see how many states of the DP. Now next thing we should calculate is the number of states of DP, right? That's how you should approach problems. So the next thing which should come to your mind is that what are the states of the DP. Now if you have already done the next knapsack kind of DP, you already know that index, or you just think that index, the current index which you are at currently, that definitely must be one of our points. Okay, and what we can take at most k indices, right? It is told in the question that we can take at most k indices. So what is the current count of number of events that I have attended? I can attend at most k events, at most events which I can attend. So what is the current count which I have already attended? So this count which we must take, and another count we must take which is max so far, which means that what is the among the values, among the indices which I have taken already, what is the maximum ending index? What is the maximum ending index? So but now you should see that if this is the state of the DP, then the time complexity will be something like this index, it can go till n, it can go till k, this index maximum it can also go till n. So what can be, it can be n square into k. Okay, but this will definitely give a TLE. If you think this will definitely give a TLE. So what this is the next thing which should come to your mind is that how to remove this TLE and how to reduce one state. Now if you try to think that, do you really need this maximum? Do you really need this maximum? What you can do is that on passing uh, something, let's say what I want to say is that, let's say this is a index, this is another range, this is another range. Okay, this is, let's say, another range. So I have taken this, if this take is true, then the next event which I can attend cannot be this, because the this is, I mean, starting before it is ending. So I am occupied till this, point. So it means that I cannot attend the indexes this. I cannot, because start point is this. Okay, so I cannot attend this also, that, but definitely I can attend this. So you do binary search among start time. So you have a start time vector, you store these values, let's say these x1 x2 start values, x3 x4, these start values, you save it in a sorted array. You are already sorting the indices, as the first intuition I have told you, right? You are already sorting the indices. So in the start array, you do that. I am presently at this index. What is the next index which is feasible if I have already taken this? So let's say I have already taken this. I should move directly to this index by the binary search, and I can use an upper bound. If you don't know, I mean, if you are using some other language, just use a simple binary search. But in C++, you can use something like upper bound, which will tell you that let's say this is a vector v. You just need to pass v dot begin, v dot end. Okay, v dot end, and what you need to pass is the value above which you need to take. So it will give you the first element. This gives you the first element in the sorted index, first element in the sorted index, which is just greater than x1, okay, or value 1, okay, which is just greater than this value, okay. Then you should know that if x1 I have already taken, then this y, I should pass this y in this thing, and I should take that, I should tell that, I mean, this starting time should be greater than this value y. Okay, so that's we can get using the binary search, and it will take log n time to do this. So now you can understand that this thing, now you can easily understand that this n square into k, one of the states we have reduced now. Now we have reduced one, ended up in reducing one of the states. So it will be something like n into k, and instead of another n, we have log n. So n into k into log n will be our total time complexity. Okay, and if you see this sum, this value is given 1 is 6, and log n, you know, it cannot be greater than 10. Okay, I mean, you already know, right? So let's try to solve the problem. Let's try to solve the problem. I will keep explaining you everything. I will keep explaining you everything. I will start with three methods. I will do three methods exactly. I will first write the very intuitive recursive function, then I will go to memoization or catching, and then I will go to the tabulation version. Okay, and it will be very simple, very simple. If you just keep following my coding, it will be very simple and intuitive, and you will never, these are the kinds of problem, once if you do, you will never get, I mean, you will never be stopped in solving any such problems, similar problems, the next time you are solving. Okay, so let's just see how to solve it. First we will start with the recursive approach. We'll start with the recursive approach first. As I have already told you, what are the states of the DP? It will be nothing but current, index, and count. Okay, so both initially I am at zero index, and I have picked zero interval. So both are zero initially, and I need to do nothing but return. Let's say I'm writing another recursive function calc, which will give me something like events. These events, and it will start with 0 and have initially 0 and k also. But one thing you should never forget is that what I told you, uh, we should have a start index. Okay, we should have an array of start index on which we will apply that binary search, right? So we should have a start. Let's say, let it be a global vector. I am keeping a global vector start. Okay, if you see, and we will sort, first of all we will sort the indices, right? First of all, the thing which we will do is we will sort the indices. So events dot begin, okay, events dot begin, events dot end will be the thing, and we will also have a loop. Let's say for auto x, we go through all the elements. Let's say auto v, we go through all the elements in the events, and start time, the events value is nothing but start time, end time, and the value, right? Value. So I will take the start time and store it in the start vector. Okay, so start dot push back, I need to apply binary search on this exactly, right? So start value dot push starts, start is nothing but first element of this vector, the exact first element of this vector. So I hope you understood this. I hope you understood this. This is not at all difficult. Now I will write this calc function, which is nothing but a recursive function, right? Which will return me my things. So let me just copy this. Okay, we will just simply copy this, and we will have current index, we will have count, we will have k, we will have all of these things. And what should be the base case? Now you try to think what should be the base case of the recursion. So the first thing which can happen is that my count can get exhausted. So if my count is equal to k, if I've already counted, then return 0. Another thing which can happen, my current index might be at the last position, then I can take no more in, I mean, I can take no more events. So these events are, let's say, the zeroth event, ith event, one event, two event, and all of these are there. Once I reach the last one, after, like, let's say I reach n, let's say I reach the index which is n, there is no more events which I can take. So just simply return 0 here also. So I hope you easily understood what is the base case here of the recursion. Now I think you should understand how to write the uh, binary search. So first of all, I need to find which is my next start time, which is my next start time, which that is greater than my current end time. Okay, I need to have a start time which is greater than my current end time. So I will do auto iterator upper bound. So upper bound returns an iterator. If you don't know, just do nothing but start dot begin. I'm just iterating in my start value. Okay, start variable and start dot end. Okay, and that is greater than my current end time. What is my current end time? That should be greater than, right? So what is my current end time? If you see events of current means that I'm in the current event, and that what is the end time? It's start comma end comma value. So that's one. That's one. Okay. So this is the value which I have. Now if you do not, let's say I will have a variable next. Okay, each will be initialized to n initially, but if it is not equals to something like start dot end, so this means that if found, if you have found, this simply means that if found, if you have found that, just do something like next equals to it minus start dot begin. Find the index, just find the index number. So what you should do here is just find the index number. Okay, now after you have found it, uh, what index number you have find, that the next value, if I take this interval, what is the next interval that is feasible to attend, that is the next index number which I have found out. Okay, so you can understand this easily. Now there are two choices, definitely take or not take. So if I do something like take, what will be the things? Calc of events, I have taken this, I will get a value, right? I should also get a value. So events of current, I will get, if I'm taking, then definitely I will get the current value, right? That's quite obvious. So I have got my value since I've taken this interval, and now I am ready to move to the next index which is given by next. Okay, I'm ready to move to the next index which is given by next, and now also I have taken one element, I have taken one index, so my count get increased by one, and at max I can take k. So k we need to return always. What I can do, I can also choose to do not take. Then in that case, I will not get any of these values. I will not get any of these values. I will just move on to my next index. I will simply move on. I will not even count increase with the count. I will simply move on to the next index, which is current plus one, not even the next. I have not taken this index, just move to the next index. If I'm taken this index, just move to the next feasible index. Okay, this is the thing. This is the thing you need to do. Now you need to return nothing but max of take comma not take, whichever will be the value which is obtained by maximum, taking maximum amount take and not take. You just return me that. You just return me that. Now if you try to run this code, and let's check if there is any error which I committed. You see this is giving me some errors. So it is telling that n is not defined. So let me just quickly define this n. Okay, you do understand. If I try to run now, will that work? You have the accepted thing, but since this is a recursive function, do you think we will get totally accepted if we submit it? We should get a TLE, right? We should get a TLE, because what is the time complexity? In every index I'm taking, whether take or not take, I'm not catching any value. I'm not catching any value. So this will give TLE, as you saw. Okay, so we need to do a simple DP, which is very simple by now. By now, you should easily understand. If you are following my DP playlist, this is very trivial thing which you should blindly do. You can blindly do, not always, but most of the cases you can. So, what is the dimension of the DP? Current and count. Current, that can go to something indices, which is n. Okay, so it can go to n plus 1 or n, you just take it. Since this is a bottom up DP, you can just simply take n, not bottom up, top up. And index, you can just take it to be k, okay, and you initialize all of them by -1. This is the simple dp vector which you need to do, and you just need to pass this dp everywhere. You just need to pass this everywhere wherever you are calling this calc function. So you have this dp here, you have this dp here, and you also need to pass this, okay. So just do it quickly. And the thing which you need to check, that if the dp of current and count is not equal to -1, that is if it is empty, so -1 I initialize, so -1 represents empty. So if it is not empty, do not calculate it again and again. Just do it. Is something like cache memory, right? You already understood this, I guess. It is something like cache memory, so you do not calculate it again and again. You just return it. So you just have return simply. And if it is not, you do these calculations. If it is not, you just do these calculations and simply do return. Simply save my answer. Okay, save my answer in dp current count. So if you try to save this max of take comma not take, it will be something like this. And now if you try to sum it, I think everything should work fine. Let's try to see. Uh, it should get an accepted. So if you see, we have an accepted, but definitely our runtime complexity is not so good. So we will try to make it better. And if you are following my DP playlist, again, I will say that this thing which you should convert now to memoization to tabulation is also very simple. Memoization to tabulation. Now conversion I will show. Also very simple. You do not need to do much. You do not need to do much. So what I will say is that you should definitely try this on your own. Okay, so everything will be in a single function. You have this start, you also have this sorted, you have this dp vector, which I'm just bringing it down definitely. And the first thing which you should focus is filling on the base cases. As I had already told you, this memoization to recursion conversion, first you should take care of these base cases. So base cases are nothing but k and n. When count is k and when current index is n, I need to take care that it returns 0. So that is what we will follow. So I will do something like int I equals to 0 and I is less than equals to n I plus plus. It will go, it will just tell me that just take this I and take this maximum value of k and give it 0. Okay, give it just 0. Okay. So now you can also understand that you can make this j, and the k value also you need to fill up, right? The k value also you need to fill up. So this, let it be j, and for the last index n you make it 0. So these are the base cases which I have written. So I am converting this recursive function into an iterative one. The first step would be to convert the base cases for the k and n values. So for the all the k and n values of all the corresponding other states, I will just make them 0. I will just make them 0. And then what I will do is that I will write two functions. Okay, one will start, it is a bottom up dp, so it will definitely start from the back, and as it starts from the back, you just do something like j, and then k minus 1, k greater than equals to 0, k j minus minus. Now you can, I hope you can easily understand that this I represent nothing but that current index, and this j represent nothing but the count which we have taken so far. This is the same thing. So you just need to think that which things we need to copy, right? So this is definitely something which we will copy. So it's very intuitive, and I mean it's very mechanical. You don't need to think anything. Just copy these. Just copy this as you have done here. As you have done here, just you need to copy these things, and it will work just fine. It will just work fine. Uh, and definitely, you need to change those current values. So let's see. Let's see. just copy these things. Same things you see, I have just copied it, and I will replace all the current. Wherever I will see current, I will replace it by I, and count I will replace by j. So you see here I am seeing that cur is present. I just replace it by I, and remaining things are looking fine. And this also I should replace it by I. Okay, this is nothing but dp. I should write a dp here, and count I should write j. Instead of this count I should write a j here. These are the states of the dp which we need to write, and remaining things we can just simply rub out. And this another thing here is we write the dp, and I am seeing that there is a current present here, so I will convert that to I. Okay, and this count I will just make it j. I will just make it j, and that's all. That's all. You see, that's all. And this just this one is left. This will just be ij. Okay, this will just be ij. And instead of this calc, I'm writing. I am no more depending on on the calc function. I just return dp00. So dpij denotes nothing but starting from the zero index and having nothing in hand. Starting from the zero index and having a zero count, what is the maximum value which you can obtain is given by dp00. Okay, so you just do this and just remove everything else. You can just simply remove everything else, and it should work just smooth. Let's try to run it and check. Let's try to just run it and check. I think it will work fine. We have the accepted case. If we try to submit it, you see, we have an okay runtime complexity also, and a moderate kind of memory complexity. So that was all. That was all for this problem. This was definitely a doable hard kind of problem. And if you did not know this, I think you have definitely learned something new. If you like this video, definitely comment. And so that's all. That's all for this video. I will meet you in the next video. Thank you so much.